So this question is a little bit more on parallel circuits and your understanding of voltage. Really, I'd say it's your understanding of voltage. You can bring in current and resistance, but I think you can work on this using your understanding of voltage. Now we have a 12 volt power supply, and what we can do, we can choose. It doesn't matter. We can choose that one side is plus 12 and the other side is 0. So a sensible thing to do would be to say that this is plus 12 volts, and we'll say this side it's 0 volts, because that's what the power supply does. It sets one of its terminals at 12 volts, potential difference higher than the other. And we could have chosen funny values, but it makes sense to go 0 to plus 12. So we could have chosen any value where the difference is 12, but the most sensible ones in terms of explaining it and understanding it would be to go for 0 to 12. If they are connected with wires like these, then everything that's connected with the wire has to be at the same voltage, has to be at the same potential. So this one is at 12 volts and this one is at 12 volts as well. And working down on the other side, all of these connected with wires have to be at 0 volts. So the potential difference across both branches in the parallel circuit is 12 volts. And then it doesn't matter. So I could have as many branches as well. Each branch is entirely independent of the other branch. It doesn't matter what's going on in each of these branches. This branch has 12 volts potential difference applied across it. This branch has 12 volts potential difference applied across it. And I could then go in and work out the currents. The total resistance of this branch is 3 ohms, and I've got a 12 volt potential difference. So I can work out for this branch, this first branch, I know V equals IR, and I know that I is V over R. So I can say that 12 divided by 3 is 4 amps. So I've got 4 amps flowing through this one. For this branch, I have I is V over R. The V is still 12 volts, but now the resistance is 4, and this one's 3 amps. So there's 4 amps flowing through this one, 3 amps flowing through this one. And I can work that out. That's absolutely fine. Now, a 4 amp current flowing through here means 2 ohms is 2 volts per amp. You can express an ohm as a volt per amp. So we lose 8 volts going down here. So 8 volts are lost there, and then the remaining 4 volts are lost here. So I can say that X is at 8 volts because I know that 8 volts are lost doing work in this resistor, and then we drop the remaining 4 volts here. So the 8 volts are dropped here, and we end up with the remaining 4 volts dropped there. So I wrote 8. Sorry about that. That's a minor error. So 12 to 4, because 8 volts, potential difference across this is 8 volts. The difference between 12 and 4 is 8 volts. Okay, so X is at 4 volts. This point is at 0 volts. If we look at Y, we've got a current of 3 amps. So 9 volts dropped across here. So this losing 9 volts, that gives me 3 volts, and the remaining 3 volts are lost in this one. So Y is at 3 volts, X is at 4 volts. I can do those as ratios as well. 12 volts split into 3 parts is 4 volts per part. So we'll lose 4 volts, then another 4, that gets us so that's 8 in total, which gets us to 4 volts here. Then we lose another 4 volts to get us to 0. This one, 12 volts split into 4 parts. There's 3 parts here, so we go 12, 9, 6, 3, and then a final part here, 3 to 0. So if I was to connect up a voltmeter here, difference between 3 and 0 is 3 volts. Connect a voltmeter in here, the difference between 4 and 0 is 4 volts. Connect a voltmeter from X to Y, which is what I'm being asked to do. The difference between 4 and 3 is 1 volt. So the answer is 1 volt.